Now, capacitance and capacitors. First, let us study what is capacitance. Now, I have given you a body, and suppose you are giving the body a charge Q. Radius R. I have given the body a charge Q. Now, greater the charge Q, greater will be the potential. What is the formula for the potential? Q by 4 pi epsilon naught R. So as Q increases, what happens? Potential will also increase. Now, so I can say that more charge, more is the potential. So potential is directly proportional to Q, or Q is directly proportional to potential. Now, if you introduce an equal to sign, here comes a constant C, and this C is called capacitance. This C is called capacitance. Now, how can you define C? Now, many can define C in this way. They can say when V is 1, then C is Q. That means the charge needed to raise the potential by unity. Or you can say capacitance is the ratio of charge to the potential that particular charge will raise the body to. You can say it is a ratio of charge to the potential that particular charge can raise the body to. Now, unit of C is farad. Charge, unit of charge is coulomb. This is volt. So 1 farad can be written as 1 coulomb per volt. 1 farad can be written as 1 coulomb per volt. Now, on what factors does this C depend? Factors on which C depends. Factors on which C depends. Now, C depends on various factors, children. Number 1, it depends on the size of your body. Now, why? We know Q is CV, C is Q by V. Now, if you have a body and you have given the body a charge Q, radius say is A, what is the potential of the body? Q by 4 pi. If it is in a medium, then it is epsilon naught K into A. Q by 4 pi epsilon naught R is the formula, and if you have a medium, you have K. Now, if you put the value of V over here, what is capacitance? Put the value of V, Q by 4 pi epsilon naught Ka. Now, Q cancels. What are you left with? 4 pi epsilon naught Ka. Now you see, capacitance is proportional to The size, the radius. Greater the radius, greater is the capacitance. So it depends on the size. Point number 2. Capacitance depends on the presence of a dielectric medium. I'll be explaining this dielectric medium later on. So if you have a dielectric medium K, so you see, without medium the K won't be there. So greater the dielectric medium, greater will be the capacitance. Capacitance depends on K. Capacitance also depends on the presence of neighboring conductors. The presence of neighboring conductors. Now suppose, children, you have a plate, and suppose this plate is positively charged. It's a conducting plate, A. You bring another conducting plate over here. So what will happen? This side you will have negatively charged induced, and this side you will have positively charged induced. Now, bringing of this plate closer to A, what will happen? When you bring potential at A is a work done in bringing +1 coulomb charge from infinity to this point. Now, when you are bringing the +1 coulomb charge, what happens? This positive charge will repel you and the negative charge will attract. It will help you to bring the charge. So this positive charge here will increase your potential and the negative charge will decrease the potential of A. It will help you to do the work. But since negative is closer to A, its effect will be more. So what happens? This negative charge will rule. It will reduce the potential of the plate A. And what is the formula for capacitance? Q by V. If the net potential decreases, what will happen? Capacitance will increase. So when you bring a neighboring conductor near the body, what happens? The potential of that plate or that body decreases. And since capacitance and potential are inversely related, therefore capacitance will increase.